Hi everyone! In this lesson, we will go over the definition and ways to find the prime factorization of a number. First of all, prime factorization stands for finding a number string that uses prime factors only to make up the original number. And there's only one unique prime factor string for each number. And by the way, this came from the fundamental theorem of arithmetic. In the example given, we are asked to find the prime factorization of 360, which basically means to find a number string that only uses prime factors to make up 360. I'm going to show you two ways to do so. The first way is called the factor tree method. You begin by writing 360 down and then you draw two split lines underneath it. Now, write down a factor pair that multiplies to 360, such as 2 times 180. Since our goal is to break down 360, you should not consider 1 times 360 because this factor pair does not help to break down 360. Notice how 2 is a prime number. This means we cannot break it into a smaller number anymore, so you should highlight it for later purpose. 180 can be factored further, such as 2 times 90. Again, 2 cannot be factored further, so we highlight it for later purpose. Now, 90 can be factored further, such as 3 times 30. 3 is a prime and it cannot be factored further, so we highlight it again. 30 can be factored into 3 times 10, and we highlight the 3 again because it is a prime number. 10 can be factored into 5 times 2. Since both 5 and 2 are prime numbers, we are done because you cannot factor further. So, the prime factorization of 360 will be 2 times 2 times 3 times 3 times 5 times 2. This is the expanded form of the prime factorization. We can also rewrite this using exponents. Since there are 3 2's, we can group them together and write it as 2 to the power of 3. Since there are 2 3's, they can be grouped as 3 to the power of 2. There's only one 5, so we can write this as 5 to the power of 1 or just as 5. Now I want to show you how you don't have to begin with the factor pair that I choose. You can actually try other starting pairs, such as breaking 360 into 6 times 60. Since none of them are prime number, we need to break each down separately. 6 can be broken into 2 times 3, while 60 can be factored into 6 times 10. Now 2 and 3 are prime numbers, so we highlight it because we cannot factor further. 6 will be factored into 2 times 3 again, and the 10 will be factored into 2 times 5. Since all of these numbers are prime, we are done. Notice how the number string is exactly the same as the one above. This is why there will be one unique prime factor string for each number only. To summarize the factor tree method, you will start with any factor pair of your choice, except 1 and itself, as it doesn't help to break down the number. If one of the factors used is a prime number, you will not be able to factor further, so highlight it. If the factor is not a prime number, continue to factor further until you get to a prime number. You are done when all the factors are prime numbers. Another way to find the prime factor string for 360 is using the division method. You begin by writing 360 into the L shape and divide it by a prime number of your choice, because the purpose of this is to find a prime factor string. For those who struggles, it might be easier to list the first few prime numbers on the side, such as 2, 3, 5, 7, and 11. Now all you need is to try and see which one goes into 360. From the list, 2, 3, and 5 all go into 360. We will just pick 2 to begin, which is written on the left side of 360. 360 divided by 2 is 180. This gets recorded underneath the 360. From the list of prime numbers, 2, 3, and 5 goes into 180. We will just pick 2 again, which will bring 180 down to 90. Now 90 can be divided by 3, bringing it down to 30. 3 goes into 30, bringing it down to 10. And 5 goes into 10, which brings the number down to 2. Since 2 is a prime number, we are done. So the prime factorization of 360 are all the prime numbers in the list, which are 2 times 2 times 3 times 3 times 5 times 2. And just like the factor tree method, you can begin with other prime number of your choice and you will still end up having the same answer. To summarize the division method, the number should only be divided by prime numbers only, and it would be helpful to list the first few prime numbers on the side so you can trial and error as needed. You know you're done if the last number on the list is a prime number. Okay, that's it for the lesson.